Okay, today we are doing systems of linear equations, and today we're actually going to solve them algebraically. And there are two strategies that we use. One is what we call substitution, and one is elimination. So we're going to start with substitution. And there's a lot of algebra in this, so feel free to skip through bits if you need to, because a lot of it's just manipulating the equations. Okay, when we have the first method we're going to look at for substitution is when one of the variables has a coefficient of 1. So actually in this example, both of them do, and that's okay. The first step is to take one of the two equations in your system and set one of the equations so that the variable is equal, make it equal a variable. So for example, number one, first thing I'm going to do, I'm going to take this equation here. Okay, we're going to try this again. Okay, I'm going to take this equation because it's the simpler one. It doesn't matter which one you pick though. And I'm going to rewrite this as, I'm going to go minus y, and I end up with x equals 7 minus y. So that's now my new equation, okay? And then I'm going to take, so that's step one. And step two is I'm going to take that and I'm going to substitute it into the other equation. So for step two, I'm going to take my other equation, bring it down here, and I've got x plus 2y equals 10. And then what I'm going to do is take this value and replace the x in the second equation with 7 minus y. Now it's a really good practice to do this with brackets because sometimes you're multiplying it by something, sometimes you're subtracting it from something else, and you need those brackets in there to make sure that the signs all work out the right way and all of that sort of thing. So it's just a really good practice to put it in brackets. Then I'm going to simplify it. So I have 7 minus y plus 2y equals 10. Now I'm on to step 3, where I'm going to actually solve this equation for y. Okay, so I've got 7 minus y plus 2y is plus y equals 10, and then I get y equals 3. So that's one of my values, is y equals 3. And then I need to take step 4, I take this y equals 3 and I substitute it into one of the original equations. So if I go, actually I've sort of changed this a bit. I can substitute it back into the equation that I have, where I know that x equals 7 minus y. So if y equals 3, that's a 7, not a z. If y equals 3, then x equals 7 minus 3, so x equals 4. Okay? So the solution, now because this question was just x's and y's, I can write this as an ordered pair. So my x is 4 and my y is 3. Okay? So this is the answer right here. Okay? But I want to check it as well. So I'm going to check it in the other equation. So I found my x by using the x plus y equals 7 equation. So I need to substitute it into my other equation, which is x plus 2y equals 10. So I'm going to replace this is 4 plus 2 times 3 equals 10. 4 plus 6, 10 equals 10. So yeah, I'm happy with that. So there's my answer, okay? I'm going to ask you to do the other one right now. Pause the video, try the question yourself, and then turn it back on again, and I'll have my solution there for you, okay? All right, here's the work for the second question. I'm just going to scroll through it, and you can pause it so you can see the whole thing. There's my solution, 3 over 2. Comma negative 1. X is 3 over 2 and y is negative 1. And there's my checking it. Now one thing I didn't mention before is that it's absolutely essential, critical, that when you use one equation to find your, you use one equation to find your second value, we used the two equations together to find the first value, which in this case was the x. We used question 1 to find the value for y. You have to use the other equation to confirm your values, okay? Because the value you found for y definitely works in the first equation because that's how you found it. So you have to use the other equation to check your answers. And you need to check your answers on these. And if you never check your answers on anything else, please check your answers on this. Okay, now we have a second strategy, which is when we can do this by elimination, or by substitution, I'm sorry, when we don't have one of the factors, or one of the coefficients equal to 1, but we don't really want to solve for x or solve for y and introduce fractions into the equation if we don't need to. But what I can do is notice that 6y equals 2 times 3y. I'm not worried about the signs particularly when I'm looking at that, but I'm looking for something that's a multiple of something. So what I'm going to do now is I'm going to rewrite, actually let's solve question, no, this order is here. So I'm going to rewrite the larger term, which is the 6y, as a product of the smaller term, which is 3y. That means I'm going to take my 4x minus 6y equals 18, and I'm going to rewrite that as 4x minus 2 times 3y equals 18. Okay? And then I'm going to take my equation that has the 3y, and I'm going to solve that for 3y. So that gives me 3y equals 5x minus 18. And then I'm going to substitute the 5x minus 18 for the 3y in my other equation. So I get 4x minus 2 times 5x minus 18 equals 18. And then I'm just going to solve, this. So that was step 4 up here. So now I'm going to solve this equation, which will get me a value for x. So I have 4x minus 10x plus 36 equals 18. So that's minus 4x equals negative 18. Sorry, negative 6x. 6x equals negative 18, and then, divide it by negative 6, divide by negative 6. X equals 3. So there's my x value. Then I'm going to take my x and I'm going to substitute that into one of the equations. It doesn't really matter since neither of them is solved for x. So I'm just going to put this into the first equation. So I have 5x minus 3y equals 18. So that means 5 times 3 y equals 18. 15 minus 3y equals 18. Negative 3 equals 3y. So y equals negative 1. That gets me my solution of 3, negative 1. And then I need to check that. Oh, yeah, sorry, just checking something there. Okay, so I'm going to check it in the other equation. So not this one, but the other one. So I'm going to check it in the 4x minus 6y equals 18. 4 times 3 minus 6 times negative 1. Does that equal 18? That's 12. Plus 6, yes, that equals 18. Okay, there you go. And then I'm going to just do what the work actually looks like, because those two examples that we've done, it was laid out step by step. And so I'm going to show you what it would actually look like on the paper when I'm doing this as a question in my work. Okay, I'm going to work through this quite quickly. I want to make my videos a little bit shorter for you, and I think the way to do that is to sort of like hurry through the algebra, and then if you need to see it, you can pause it, see what I'm doing, refer to the printed version of these notes or the online version of these notes. But then you can get the concepts without having to watch all of the step by step by step algebra stuff, okay? All right, so I'm going to take this equation, I'm going to rewrite this as x equals 2y minus 2. I'm going to substitute that into this one, so this is going to be 4 times 2y minus 2 plus 3y equals 25. I'm going to solve this for y. And then I'm going to substitute my y equals 3 into this one. So this is going to be 2 times 3 minus x equals 2. Oh, I could have actually done it into here, would be just as good. X equals 2 times 3 minus 2, so x equals 6 minus 2 is 4. So my answer is 4, 3, brackets 4, 3. And then I'm going to check in the other equation, so that's this one. And it worked. So there we go. There you go. Let's do another one when the terms are related by multiplication. Okay, I'm going to take, oh, I noticed that I've got a 3y and a 9y here, so I'm going to solve this one for 3y. And I'm going to rewrite this one as minus 3x minus 3 times 3y, and then substitute that in there. I made a mistake there. That should have been 6. 6 equals 6, yes. Okay, so I'm happy with my answer. Okay, so that is it for checking, for working by elimination, or sorry, by substitution. I would recommend, I'm going to actually pause the video, stop the video here, and do a second video for solving by substitution, because it's definitely worth you doing some practice of this before you look at the second strategy. Okay, see you later. Bye.